We've seen that the for each loop can be used to execute a number of statements for each item in a list. And it can also be used to execute statements for each word in a text or for each letter in a text. And these statements that are executed in the for each loop, we call them the body of the for each loop. And there are also other ways to repeat statements. One of them is the while loop. And the while loop also has a body, and the body is executed repeatedly. And for the while loop, it is executed when the condition after the while is true. And as long as it is true, the body will be repeated. Here's an example. I have here an algorithm that computes the greatest power of 2 that is smaller than 1000. So I keep track of the exponents, which I increase every time. Here it is variable exponents, and the power that I compute, I store it in results. So I start by assigning the value 0 to the exponents and results. And here we have our while, and I want to increase my exponent and to compute new results while the result is less than 1000. So result is 0 when we start, so of course the first time when we encounter while result is less than 1000, this condition is true. So this is the condition, just like the condition in the if. So the first time what happens, exponent is incremented by 1, so exponent becomes 1, and results is the 2 to the power exponents, so that's 2 to the power 1 is 2. And we reach the end of the while loop. So now the condition result is less than 1000 is evaluated once again, and it's still true because 2 is less than 1000. So again, exponent is increased, and the result is computed. So now we get to 4, it's still less than 1000, etc., etc. Finally, we go from exponent 9 to 10, and when we reach 10, the result gets 1024, so that's greater than 1000. So result is less than 1000 is not true anymore. So the while loop stops, and the algorithm resumes with the statements below the end while. So the algorithm resumes here, continues here, and the exponent is printed. And here we see that things go slightly wrong, because now it will print 10, and my goal of the algorithm was to print the largest exponent that yields a power of 2 that is smaller than 1000. So I went one exponent too far, so I need to subtract 1. So the result will be 10 minus 1 is 9. So this demonstrates the use of the while loop, and very much alike is the do while loop, and they are almost the same. The only difference is that the condition of the do while loop is checked at the end of the loop, not at the beginning, and that means that the first time that the body is executed, it is executed without checking if the condition is true. So you know that when you're using a do-while loop, the body will be executed at least once. And when using a while loop, the body may be executed 0 times. And as you see here in this example, I used the same algorithm as above here when I used the while loop. And here I left out this line, result is 0. Why can I leave that out? Well, what happens if I leave it out in the first algorithm? If I cross this out, we've got a problem, because then the algorithm here in the while loop, it refers to result, but result has no value. It's an unknown variable. So this is clearly wrong. So we do need here result gets assigned 0. But in the other algorithm here, where we use the do while loop, we can leave it out. Why? Well, let's have a look. We still have to start with giving exponent value 0, and then we have our do while loop. Here is our body. Exponent is incremented by 1. Exponent becomes exponent plus 1. We compute the results in the same way as above. Results becomes 2 to the power exponent, and then we check our condition. Our condition result is less than 1000. And here you can see that result is known because it has been computed in the line above. Result becomes 2 to the power exponent. So we do not need the result becomes 0 here in the beginning. We don't need it anymore because it is already initialized here at this line. So in this case, it turns out it's a good idea to use the do while loop instead of the while loop.